Notes 5. Okay. So we're going to go through shape, center, spread, and then calculate the probability. Just like we did with like the top 3 things on that giant sheet of paper. Same process. It's just different format, basically. So for the shape, I'm going to go shape, center, spread. So for shape, I'm looking to see if it is approximately normal or not. So there's 2 ways that can happen, and they're both not applicable. So I know that the distributions are approximately normal if what? There's 2 things. And it's got to be greater than or equal to 30. Well, I took 8 boys and 8 girls. 8 is not greater than 30. Good. Did I get that? 8 is less than 30. Or what's the other way? They explicitly state that the population is normal. Did they do that? Kinda. They gave me a standard. No, I would say they didn't. So let's just. So we're gonna have to say we assume both populations are normal. Didn't really tell. You're gonna get a lot of questions that are not like calculate this. It's like, would you be able to do this or not? Does it satisfy this condition? Answer your question.
So if it doesn't explicitly show you that it's abnormal, is the answer just
So here's the in a written out free response, one like this. So because they wouldn't do it. In a multiple choice, they might give you this question and say, are the conditions met? And then you'd be like, no, they're not. Because I don't have large enough sample size. It doesn't tell me it's all condition. But in the like written out, they're not going to want you to stop there and not do the problem. So you just assume. Does that make sense? The differences. Okay. Center. This is garbage again. So what am I looking for that I don't see? Stop saying independent. See, it's coming. It's coming. What am I looking for? I need randomness that doesn't say, so I'm going to have to assume both SRS. And then once I do that, I can say what the mean is. I am going to not use x1 and x2. I'm going to use xg and xb. So the mean of x bar. Do I want to do boys minus girls or girls minus boys? I'm going to do boys minus girls because that's the order it's on there, and if I switch that, I get confused. So this is the like distribution that I'm looking at. So I'm taking the sample mean of boys minus girls, taking the sample, subtracting boys minus girls, taking another sample, subtracting boys minus girls, putting all those on there. Since I'm doing it randomly, I should be able to assume that the mean of my distribution will be the same as the mean of like the population data. So the mean of boys is 175, and the mean of girls is 165. So the average difference is 10. Again, the idea is if the average difference in the population is 10, the big picture, and I'm taking small samples, in theory, my difference will all be 10 also, because I'm doing it fairly. All right, Alright, shape center and then spread. Gunner, what do we need for this one? We need independence. So I am pretty sure that 8 is less than 10% of like all 15-year-old boys. I'm just gonna do this boys/girls. And then once I've established independence, what am I allowed to say? What am I allowed to use? What am I allowed to find? Standard deviation. So the standard deviation of X bar boy minus X bar girl. So you take the standard deviation of the original one, which is 8, square it and divide by the sample size, which is also 8. That's really annoying. So let's just put 8 everywhere in the problem so no one really knows what 8 represents what. That's perfect. So this 8 is the standard deviation being 8, and this 8 is the sample size. It's 8 and 8 again. So I guess maybe that's why they did it, because now it's like so it's 4, right? So the standard deviation is 4. Do we hopefully see where the 8s are coming from? I'm going to erase all that in a second. So any questions on that before I plow ahead there? So all I just did was prove that this is what I have. Approximately normal. That was the shape. That's the center. And that's the spread. And this is boys minus girls. That's the order that we did it. So the question asks, what's the probability that the mean height of the girls will be higher than the mean height of the boys? So first of all, is that more likely than 50% or less? It's less because the girls' height averages are shorter. So if you get an answer that's higher than 50%, that should be like a little signal that, wait, I might have done something backwards. Let me go double check. But what I want, if the girls have a higher score, is boys minus, so girls have a higher score. You're going to do a lower score minus a higher score. Do you want a negative number or a positive number? You want a negative number. The girls are going to be higher. You'll have a smaller height minus a bigger height, so you want to know when boys minus girls is less than 0. Because this means girls are taller. So the whole first slide I had up was just like proving that we can do it, which I understand probably gets annoying, but it is really going to help you when you start looking at multiple choice questions because you'll have seen it a bunch of times. And now the math is just based on what we have here. So normal CDF. I want a negative number. So negative numbers go between what and what? Negative 999 and 0. Then I tell the calculator the mean and the standard deviation. Well, that's why I just spent that time figuring out. And we would type that in and see what we get. And if it's not smaller than 50%, it's, you gotta double check. I think it's really small. I got 0.0062. Hello? No. No. Alright, yeah. Did you get that also? 0.0062? I think it was like 09 after that, so 621. Questions on it? Any of that process? Like justifying all the 3 things or finding the math part of it? So do number 5. I don't want this wording to take away from like focusing on the actual problem. So you see where it says isn't 100 hours more? Let's just like annoy. Let's just do is. Isn't, we would just like if it's 40, we'd make it 60. It's just the opposite. But you're just adding like a layer of difficulty there that is not really helpful. So you gotta go through and justify all the conditions. And then do that. You don't need to assume normal because your sample size is way bigger than 30. But you do need to assume random, right? It doesn't say random. This whole unit has felt like kind of disjointed to me because all the time we missed. I'm hoping in the next couple days when we start like synthesizing things, you'll start to see the big picture and understand what we're trying to do. You guys get 63.5 for the standard issue. You didn't get that? 5 1. I cycled it. So do 500 squared. 5 by 300. That's like 833. Oh, you gotta hit the square root. Yeah. So you take the square root there, then you take the square root. Yeah. You know what I mean? You're doing it twice. So figure out the stuff inside first without the square root, but then take the square root like all that. checks here. So I've got approximately normal, 200, and then 63.5. And I did A minus B. And you could do B minus A. If anyone did B minus A, everything's still going to apply. And you'll still end up with the same answer.
Does that work for everything or is that just for this problem?
Like that you can switch the direction, everything. So there's no way of knowing like what's the correct way. Like you just pick a way, and as long as you do everything in that direction, you're good. All right, so now they're saying calculate the probability that the average life of sample A is 100 more than the average of sample B. So that means A has to be bigger than B plus 100. Does that make sense? So it's got to be, A has to be bigger than 100 more than B. Well, my distribution was set up as A minus B. So I've got to turn this into something that is A minus B. So I'm just going to like subtract B from both sides. And then wouldn't this say A minus B is greater than 100? Some of you might have just jumped to that right away. And that's fine. Like I'm just showing different ways to get to it. And then I have the mean, the standard deviation, and I have what I'm looking for. Now we can go normal CDF. Greater than 100 would be 100 and then 9999999. Tell the calculator the mean and standard deviation. Label if there's a free response person grading it. I got 0.942. How many got that? Nice. Questions? This part? No. That was just like my teaching. Okay, that's all I got. I'm going to throw more con on. You don't have to say it right now. Finish all the con.